Today we are going to learn how to write exponential functions given points on a graph. And so we want to talk about how to get the equation, get the function, and we want to talk about what the graph is going to look like as well. So the first thing is that you have this general form of an exponential function. Just like if you were doing a linear function, you'd have y equals mx plus b. If you're doing an exponential function, you have y or f of x, whichever one you're using, equals a times b to the x. So notice exponential, x is in the exponent. A and B are both going to be numbers. And so it's going to be our job to figure out what A and B are. So what's going to happen is you're going to be given 2 points. So let's say we were given 212 and 336. Okay, so what we want to do is we want to go back to that function, f of x equals a times b to the x, and we want to fill in some values that we know. I'm going to start with the 3 and the 36 because those are the larger numbers, and I can kind of see a few steps in front of me, and once you do this a few times, you'll kind of get the feel for things. So the f of x, or the y coordinate, is 36. We don't know a, we don't know b. The x-coordinate is 3. Going back to Algebra 2a, we don't have enough information here to find a and b. We have 2 unknowns, which means that we need 2 equations. Good thing we have another point. So I'm going to do the same thing with the other point. The y-coordinate is 12. Don't know a, don't know b, and the x is 2. Okay, so I'm going to use elimination to do this. When you were in Algebra 2a and you were doing elimination, you use positives and negatives because you were adding and subtracting. We're not adding and subtracting here, we're multiplying. So I'm going to use elimination, but I need to do the opposite of multiply. And so the opposite is divide. So I'm going to divide corresponding parts. 36 divided by 12 is 3. Here's the elimination. A divided by a is 1, so that a goes away. B to the third divided by b squared is just b. So what I've just found out here is that b equals 3. Okay, so b equals 3. So I'm going to go back to one of the equations that I had. I think I'm going to go back to the 12 because the numbers are smaller. I still don't know a, but I now know that b is 3. So this is 12 equals, what is that, 9? Divide by 9 on both sides. So 12 over 9, but 12 over 9 can be reduced because 3 goes into both of those, so that's 4/3. So what I know is that f of x equals a is 4/3 times my b is 3x. So that's my function right there. Okay, so now that I have my function, let's talk about graphing this function for a second. If I wanted to make a table of values, perhaps the first thing I might do is plug in a 0 for x. And if I plug in a 0 for x, that's going to be 3 to the 0, and 3 to the 0 is 1. So if I plug in a 0 for x, all I'm going to get out is 4/3. So I plugged in a 0, I got out 4/3. Okay, when I plug in a 1, I get out a 4. I mean, you can verify that. When I plug in a 2, I get out a 12, which was one of the points I was given. 3, 36, which was another point that I was given. So the thing about this also is that I can plug in negative numbers as well. And what's going to happen is when I plug in these negative numbers, the negative is going to be an exponent, and so it will flip my my value into a fraction. So like on this -1 right here, what I'm doing is f of x equals 4/3 times 3 to the -1, which is 4/3 times 1/3. And so that gets me 4/9, which is a fractional. If I plug in a -2, I think I could get 4/27. I could have done that incorrectly, but perhaps you should verify that I did that. All right. Okay, I'm going to get rid of this. But the point is that if I go, with my x's, if I go positive x's or negative x's, then what happens is I get fractions versus integer values. I never get negative numbers for my y. So when I go over here to graph it, I know that the y-intercept is 4/3. And what's happening as I go from x of 1 to 2 to 3 to 4 to like keep going is that this graph keeps increasing. As I go for -1, -2, -3, so I'm decreasing like that. So remember that I read from left to right. So I would call this graph generally increasing. It's called exponential growth. And to point out, remember that my y's are never negative. There's an asymptote right here. There's an asymptote at y equals 0. Let's see, do I want to point out anything else? Yes, I do want to point something else. If you take this 4/3 and multiply it by 3, you get 4. If you take this 4 and multiply it by 3, you get 12. Multiply by 3, multiply by 3. Oops, that's not a multiply by 3 because that's going the backwards way. Okay, so anyways, the point is that what I'm doing is I'm repeatedly multiplying by the same number. And that same number happens to be that b part, right? Because this is my equation, y equals 4/3 times 3 to the b, right? 3 to the first, 3 to the second, 3 to the third. That just means more 3's. So what I'm doing is these y values are getting multiplied by 3 repeatedly. That's the same thing as a geometric sequence, right? That's why we did geometric sequences first, is because I knew that the whole point of this unit was this exponential stuff. Okay, let's do another problem. Let's say that we had the points 1, 243 and 3, 27. And we needed to come up with the exponential equation. So I'd go back to this and and what's going to happen here is I think I'm going to plug in the 1, 243 first, just because that's the larger number. So this is 243 equals, I don't know A, I don't know B, to the first. All right, then I'm going to put in my other point. My y is 27. A times B to the third. I wish I had not have done that. Can I reverse these? I'm going to put this 243 on the bottom. Okay, I'm going to do the same thing that I did before, which was divide. And so what I have is I have 27 over 243. I'm sure that that reduces to be something, but I'm not quite sure what it is. 3 will go into both of those. A divided by A is 1. B to the third over B to the first is B squared. So I need to solve this B squared thing. I'm going to take the square root of both sides. And when I take the square root of both sides, I'm going to end up getting a 1/3. I know when I take the square root, it's a plus or minus, but here we're going to deal with positive numbers, so I'm going to get out that B is 1/3. Okay, so now I'm going to go back to one of the equations, probably the 243 one, because it's a B to the first power. So 243 equals A, and then this is 1/3 to the first power. And so 243 equals 1/3 a. I like to get rid of fractions by multiplying by the reciprocal on both sides. And so when I multiply by the reciprocal on both sides, I think I get out a 729 if I did everything correctly, which means that my function is 729 times, make sure you put parentheses around your 1/3 to the x. Okay, so just like the last one, I think that I want to take a look at a table or graph this one. And so if I go to a table, so let me just look at my function for a second. 729, 1/3 to the x. I can plug in a whole bunch of numbers here. If I plug in 0, 0 is the easy one. It's going to give me that 729. That's that y-intercept. So this a right here will always give you the y-intercept. Because when you plug in 0 for x, this part goes away right there. Okay, if I plug in 1, then I get out 243. That was one of my points. If I plug in 2, I get out 81. If I plug in, okay, so if I plug in -1, what am I doing over here? What's my craziness? Why did I not start with -2 and then go to -1? Okay, if I plug in -1, I'm going to get 2187. And if I plug in -2, I'm going to get 65, 61. You should really check me on this because I definitely make mistakes. And the other reason to check me is just to make sure that you can plug it in correctly and get the correct numbers. Okay, so when I go to graph this, I'm going to have incredibly large numbers that I'm dealing with. So what happens is my y-intercept is at 729. Okay, so it looks like what's happening on this negative side is it's up and it's coming down. And then on this positive x side, I'm getting something that keeps going down. Now, as I keep going down, there's no way I'm going to be negative, which means that there's an asymptote right here on the x-axis at y equals 0. Remember that when you read from left to right, you do the same thing on a graph. You read from left to right. This one is decreasing from left to right. This is called, I'm going to erase this. This is called exponential decay. Not sure if you've done that in chemistry or not. Usually it comes up in chemistry with half-life of radioactive material, where the exponential growth comes in a lot of times with populations, and it could be like bacteria populations or city populations or something along those lines. And notice that this is also geometric. The common thing that you're multiplying by each time is 1/3. And that happens to be your b, so that should make sense. Okay, go have fun writing exponential functions.